All right, welcome to lesson 10.3. We just finished up lesson 10.2 talking about factoring and solving some equations with square roots, but in this particular one we're going to talk about a process called completing the square. All right, so let's just dive in and see how this turns out. Sometimes a quadratic equation is not factorable. We talked about that earlier this year. Sometimes you cannot do IM factoring. Sometimes you cannot pull a greatest common factor out. So we already know that there are some equations that cannot be factored. We didn't see many of those in the last lesson because I made them all nice that you were able to factor them so you could solve them. But sometimes you cannot factor certain equations. Also, sometimes you are not able to solve quadratic equations that need to be solved with square roots. Okay, sometimes you cannot use a square root to solve a problem. Now again, I didn't give you any of those in the last lesson because we were specifically talking about square roots, but sometimes you cannot use square roots to help you solve a problem. So if an equation is not factorable and you cannot use square roots to help you solve it, this is when we can use the process called completing the square. So this might be, a lot of you might like this process actually a little bit better than factoring or square roots. You can always use completing the square for anything. Okay, you can always use completing the square. But some of us like factoring or square roots more just because it's a little bit quicker. But you can always use completing the square, this process that we're going to talk about in this lesson, to solve anything. Okay, so the reason it's called completing the square is because we will find a perfect square. Perfect, that should be a C. Perfect square to help us solve the equation. And I mean, I could go through and explain this little diagram that kind of shows why completing the square works, but I see a bunch of letters and a bunch of arrows and a bunch of things going on over here. I'm just telling you that the reason it's called the completing the square is because we are going to use this little piece right here. Notice how it's a perfect square, okay? It's being raised to the power of 2. This is what we are trying to find in order to complete this square idea or picture right here. So it's called completing the square because we're going to try to find a perfect square to help us solve the equation. All right, so let's give maybe one of these a shot. All right, so if we take a look at the little chart or diagram you have on your paper, we're going to go through the different steps that completing the square, that process entails. And we're actually going to look at an example as we go through the steps. So I think it helps to go through step by step and actually see what that step means. So let's first of all just talk about our little problem right here. We have x squared plus 10x minus 3. Notice how this is not able to be factored. It fits the IM profile, but there are no numbers that multiply to -3, but also add to 10. Okay, so factoring, not the correct method for this one. We could also, it would not be able to use square roots because notice how we have 2 x's going on in this case. Usually we're only able to simplify or solve a square root or use a square root to help us solve an equation when there's only one x. Because when there's only one x left at the end, we can square root it to get rid of the little power of 2, and we have our solution. Okay, but in this case we have 2 x's, so square roots would not be the way to go. So this one is not factorable. We could not use square roots, so this is when completing the square would be the better bet. So let's go through the steps of completing the square. The first thing we want to do is move the constant number to the other side of the equation. So what I mean by constant is this -3 right here. It's just a number all by itself. There's no x and there's no variable along with it. So we want to move this number to the other side of the equation. So if I want to move a -3 over, we need to add it. That way this goes away. Okay, so what we're actually left with is x squared plus 10x equals 3. Okay, that step's not too bad. We just want to move the number all by itself to the other side. Step number 2 is a pretty big one. Most of the ones that we're going to do not need this step, but I do want to go over some that actually require it. So step number 2, it says make sure your a value is 1. If it is not 1, we got to divide every term by a. And what I mean by a again is if you take a look at your equation, it's already in standard form. We have an a value of 1. we have a b value of 10, and we have a c value of -3. So the constant number, that c, that constant, was moved to the other side, and in this particular example, our a value is 1. So we don't need to worry about dividing anything by this number out front. Okay, so we've got to make sure our a value is 1. So maybe in this block, we'll say the a term, the a term is 1. Okay, so we don't really need to worry about this step. We are going to go through an example later in this lesson where it is not 1, so we'll worry about that when we get there. Let's talk about step number 3. Okay, so find half of b. So again, looking at your standard form, our b value is 10, and we want to find half of it. So let's just divide it by 2. Half of 10 is 5. Okay, so we found half of b, but then it says and we got to square that value. So this 5 that we found, we want to square it. So 5 squared, 5 times 5, gives us an answer of 25. All right, so that's step number 3. We found half of b, we divided it by 2, and then we squared that answer. This is where it might get a little tricky for some people. We want to add this value. So we're going to take this number 25 from step number 3, and we're going to add this value to both sides of our equation. So notice how up here we kind of change the way our equation looks. This is the one that we're going to focus on. So if I add 25 to the left-hand side and I add 25 to the right-hand side, we might be able to combine some like terms like this step 4 says a little bit later. So let's just first write out what it might look like if we add it to both sides. We have x squared plus 10x, and then I want to add 25, maybe on the end. And then this side had a 3, but I need to add that as well over here. Remember, whenever you change one side of an equation, you got to do the same thing to the other one. You want to keep your equation balanced. That way it's always equal to itself. Just like up here, how we added 3 on the left, we got to make sure we add 3 on the right. So when I add 25 to both sides of the equation, I'm not changing the value of it, I'm just changing the way it looks. Okay, the value's not changing because what I did to one side, I did to the other as well. Okay, so we added 25 to both sides. Now let's combine some like terms. Looks like these are some like terms over here. 25 and 3 can give me 28. But I don't have any like terms over here, so really these are the only like terms I can combine. But step 4 goes on to say, factor the quadratic equation. So the quadratic part is on the left-hand side because we have this little squared. Now remember, our beginning problem was not factorable. We were not able to think of two numbers that multiplied to -3 but added to positive 10. But notice how now that we changed it, it actually is factorable. If I think of two numbers that multiply to 25 but add to 10, that would be 5 and 5. But since I have two 5s, I can just write my two factors as x plus 5 squared. Okay, so really, I mean, if you want to think about it, it would look like x plus 5 and then another x plus 5. That's a 5. Oops, there goes my pen. These should be 5s. Okay, but since I have two of them, I can write it as x plus 5 squared. So this is what some of you might start it as, but try to rewrite it because you have two of them. You can kind of condense it or simplify it with this little power of 2. Okay, so step number 4 is pretty big. You have 3 things you got to do. Add the 25, in this case, to both sides, combine some like terms, and factor the other side. But I think it's all different things that we are able to do. Now that we have this equation, let's actually figure out what x is. And look at this. Notice how we started with 2 x's, but now that we changed the way it looks, we only have 1. So since we have 1 x, this is when we might actually be able to use a square root. And we can actually do that. If I want to, or go to step number 5 here, it says take the square root, because after all, I'm trying to solve for x. I can get rid of a power of 2 by square rooting both sides. So if we do that, we get, we have x plus 5, because the square root and the 2 cancel, and then over here we have plus or minus the square root of 28. Okay, but we actually might be able to break 28 down. If we can think of a prime number that can go into 28, we can have, let's see, we have a square root of 4 and the square root of 7, but the square root of 4 can simplify to 2. All right, so we have 2 square roots of 7. All right, so if we continue on with the next few steps, this is the last thing that we just finished on the last slide. If we continue through the last 2 steps, remember our goal is to solve for x. We want to get x all by itself. So the very last thing we got to do is subtract 5 from both sides. So we would get x equals negative 5 plus or minus 2 square root of 7. Now some of you can leave your answer like this. I know a lot of you like to leave your answer like this, but just like when we graph, sometimes we're going to have to simplify it just a little bit further. We might have to use a decimal to help us graph it. So let's actually see what this turns out to be when we use our calculator. So we'll bring that up. Okay, so we have negative 5 plus 2 square roots of 7, and that gives us, maybe we'll say 0.3. And then if we try negative 5 minus 2 square roots of 7, we will get negative 10.3. All right, so just in case we were graphing, just in case we had to use the decimal answer, that's what you guys can write. So completing the square, if you take a look at it, I know I wrote down 7 steps, so some of you might think that's quite a lot, but it's a lot of things we already know how to do. We can divide by 2, we can square something, we know how to add numbers, we can square root, we can solve for x. Okay, it's a lot of stuff that we already know how to do, it's just that we're putting it all together. So let's actually try another one, and without the steps. Okay, you guys can always reference the steps if you have to, but let's try to do one without the steps. All right, so let's check out number 1. We're going to solve this quadratic equation by completing the square. So maybe if you think about step number 1, okay, step number 1 is to move the constant term to the other side of the equation. Now remember, usually we set these equal to 0, just like when we talked about square roots. Same thing going on here. So if I want to move the constant term to the other side, we will add 12. Not too bad. And then if we go on to step number 2 said to make sure your a value is 1. Now this is a big one, okay, because this one is actually not 1. The a value is 3. So if we go back to step number 2, okay, make sure your a value is 1. If it is not 1, divide every term by a. Okay, so we said our a value was 3. I want to divide every single term by the a value of 3. Okay, so we're gonna make sure that we get an answer of 1, because 3 divided by 3 is actually 1x. So if it is not 1, we gotta turn it into 1, and we can do that by dividing by the actual number itself. So we'll divide every single number by 3. This negative 6 can become a 2, and then the 12 can become a 4. Okay, so we always want the first, kind of like I am factoring, we always want it to start with a 1. And if it doesn't start with a 1, you got to make sure you turn it into a 1. Okay, so step number 2 is done. If we think about step number 3, we got to find the b value, which is negative 2. Now we got to take a look at this one. Okay, so before our b value was negative 6, but notice how in this process our equation is changing just a little bit. Our new b value is negative 2, so that's what we should be focusing on right now. And we want to find half of it, so if we divide it by 2, we get an answer of negative 1. Now, we still got to go on and actually square this value. So negative 1 squared is 1. Okay, so this is my new equation that I'm focusing on, because I'm changing the one that we started with. Okay, so next step, we got to take this value of 1 and add it to both sides of this equation. So we have x squared, okay, you can write the 1 if you want to, but we have x squared minus 2x, and I want to add 1 to this side, and then the other side just has a 4, but I need to add 1 there as well. Okay, if you add it to one side, you got to add it to the other. The next step, or continuing with this step of adding it to both sides, we want to combine some like terms. Okay, 4 and 1 give us 5. But we want to factor the left-hand side. So if we think about two numbers that multiply to 1, but add to -2, okay, that would be x minus 1 and another x minus 1. But again, since I have two of them, I can write x minus 1 squared. Okay, so we're gonna make sure we write it like this because it's actually going to help us solve it. So now that we turned two x's into one x, we can go ahead and solve this by using square roots. Okay, we want to figure out what x is. So let's get rid of the power of 2. We can square root. So we're left with x minus 1. And the square root of 5 cannot simplify, so it just has to stay the way it is. Don't forget that plus or minus. I still have some people forgetting that. Okay, when you take a square root of both sides, you always need that plus or minus. Last step we gotta do, add 1 to both sides. So x equals 1 plus or minus 5. All right, so some of you might want to leave your answer like that, perfectly all right. Other times we might want to use the decimals. So I think if you were to type this into your calculator, decimal representation would be 2.3 and -1.2. Okay, you can check that if you want to, but I'm pretty sure that's what you would get if you did 1 plus the square root of 5 and then 1 minus the square root of 5. So either one, okay, can't go wrong with that. You can leave it as a square root or you can write it as a decimal. All right, so now it's your turn. I want you to take a second and pause the video and try number 2. Go. Okay, so let's check out and see how we did. Remember step 1, you want to move your constant term to the other side so we can add 51 over. Next thing, we got to make sure that our equation, our a value is 1. And if you take a look at what you have right here, it is 1. Okay, it's a little invisible 1, so we don't have to worry about dividing by anything like we did in the last one. So we can continue on with the process. Our b value is -8. Okay, if we find half of it, that gives us -4. And when we square it, we're finding that perfect square, we get an answer of 16. So we can take this answer 16 and add it to both sides of our rearranged equation right here. Okay, so continuing on, we can combine the like terms. 51 and 16 gives us 67, but then we can also factor the left-hand side since we changed the way our equation looks. So two numbers that multiply to 16 but add to -8, we get -4 and -4, but again, since there are two of them that are exactly the same, we can rewrite it as x minus 4 squared. All right, so from there, I think it's pretty simple for us to do this step because we talked about square roots in the last lesson. We can square root both sides to get rid of the little power of 2, so we get that plus or minus 67. To move the 4 over, we can add 4 to both sides. So maybe you left your answer like this, okay, 4 plus or minus 67. Maybe you actually found the decimal answers, 12.2 and -4.2. Either way, okay, you're good to go. So I hope we did really good with that one. All right, one last thing we're going to talk about with this completing the square is how it's useful to rewrite a standard form equation into a vertex form equation. So we're going to change the way our equation looks. We're going to change it from standard to vertex. Okay, so in I think the very first lesson, this 10.1, we talked about going from vertex to standard. Okay, that's when you kind of had to break it apart and use the FOIL process or distribution a couple times. Okay, but this time we're going the other way. So instead of breaking it apart and distributing, we're going to use this completing the square process to change standard form into vertex form. Okay, so since we're going to use completing the square, the same steps apply. So let's take a look at our equation. And we will set it equal to 0. First thing we got to do is move the constant term over. So we got x squared minus 8x equals -11. We got to make sure our equation begins with a 1, and if we take a look at it, okay, it does. So we don't have to worry about dividing by anything. So we can go on to the next one. We got to find our b value, which is -8. Half of that is -4. And if we square that, we get an answer of 16. Okay, so this is the magic number that we got to add to both sides of this equation. So we're going to put it once there and once over here. So we have x squared minus 8x plus 16, and then we have negative 11 plus 16, okay, added to both sides. Combining some like terms, negative 11 and 16 gives us 5. And over here, two numbers that multiply to positive 16 but add to negative 4 is negative 4 and negative 4. I'm sorry, negative 8 up here. Two numbers that multiply to 16 but add to negative 8. We have negative 4 and negative 4, but since we have two of them, okay, we can write it squared. Okay, now in the process that we've done so far, this is when we would square root both sides, we would add the 4 over. Okay, what we talked about is solving for x, but we're doing something a little bit different here. Okay, we're changing a standard form into a vertex form. So if you remember vertex form, it looked like a times x minus h squared plus k. Okay, and normally we had like this f of x out front, okay, because it's a function. So here's a vertex form. Notice how what we have up here kind of fits the format. Okay, we have an x and a number with it on the inside. It's being squared. Our little a value out front is 1, just like we said it was over here. But in this particular case, we have a number on the other side of the equal sign, but we want that number next to this little parenthesis group that's being squared. So I want to move this 5 to the other side. So if I do that, if I subtract 5 from both sides, I get x minus 4 squared minus 5. And if I move that over, I know it's equal to 0, okay, but we can also think about this 0 as f of x, because there really isn't anything left over there. We'll just say it's our function f of x or y or something like that. Okay, so there's our vertex form, and since this is vertex form, we should be able to identify the vertex. So let's go ahead and do that. The vertex is the opposite of this number. So the opposite of negative 4 would be positive 4. That's our x value. And the outside number, this negative 5, just stays the same as our y value. So there's our vertex. Okay, so this completing the square process is very useful to converting a standard form into a vertex form. Some of you might like doing this. Okay, I think it's kind of fun how we keep this process over and over again, but maybe that's just me. All right, so let's try one more. Okay, we're going to convert another standard form into a vertex, and we're going to identify the vertex. So let's set our equation equal to 0. And our first step is to move the constant term to the other side. All right, so negative x squared minus 6x, and we get positive 11. Okay, step number 2 is to check to see if our a value is 1, and we definitely got to be careful in this case because it is not 1, it's actually negative 1. Okay, so that means we got to divide every single term by negative 1. Maybe we'll do a little side note over here. A equals negative 1, so we got to divide everything by negative 1. Negative 1 divided by negative 1 disappear. All right, so we're just left with x squared. Negative 6 divided by negative 1 is a positive 6. And then 11 divided by negative 1, we got a negative 11. All right, so let's go into step 2. We got to find our b value. Our b value is 6, because remember, we're changing the equation. Okay, we got to go off of our last step. Our b value is 6. Half of that is 3. And if we square that, we get 9. Okay, so we're going to add 9 to both sides of our equation. So we have x squared plus 6x plus 9, and that equals negative 11 plus 9. If we combine some like terms, negative 11 and 9 give us negative 2. And if we factor the left-hand side, two numbers that multiply to 9 but add to 6, we have 3 and 3. But since I have two of them, that means I can write x plus 3 twice. Okay, so our goal is to get this into vertex form. We're not solving for x like we did in the beginning. We're trying to write it as a new equation. So I want to move this 2 to the other side. We can do that by adding. So with nothing left there, we can just put our little f of x. And we have x plus 3 squared plus 2. Alright, so far it's just like the one we already did, but we need to be extra careful with this one because again, if you remember vertex form, we have the a out front, it's x minus h squared plus k. Alright, so if we take a look at the last one we did, okay, over here we didn't have to divide by anything because our a value was 1. And notice how up here, okay, our a value is still 1. Okay, we don't have to write it there, but it's still understood to be a 1. Over here, we said over in the second step, our a value was negative 1. But if we look at our process of what our answer is looking like so far, I don't have a negative 1 out front. It's actually a positive 1. So since we identified a as negative 1 at the very beginning, we got to make sure we put that negative 1 into the a position because that's what we need in this vertex form. The a in standard form and the a in vertex form are the exact same number. So even though it's not showing up in this process, we need to make sure we put it there in the final step or at the very end. So you should have a negative 1 or a negative sign in front here because that's the a value we identified at the very beginning. Okay, this is a huge step. So maybe star it. Okay, remember that. You always got to make sure that your a value from step number 2 in the completing the square process matches what you have in your final equation. So in this case, we need a negative 1. If we go on to identify the vertex, we need the opposite number on the inside, so that would be a negative 3, and the outside number stays the way it is, so it would be 2. So if you were graphing this, your vertex would be somewhere around the coordinate negative 3, positive 2. Alright, so I hope that you guys are enjoying the completing the square process. It's going to get really easy the more you do it and the more you practice it. So remember, completing the square is when you cannot factor and you cannot use square roots, but completing the square works for everything. So even if you forget how to factor or how to use a square root, you can still use this process. Okay, so we're going to do a little bit more practice next class, and I'll see you then. Bye!